For the purpose of this demonstration, we've created a simple NFT card. We used 4 tokens for this card that are corner radius, typography, color, and opacity. We will show you now how, by modifying only these 4 tokens, we can apply a totally different theme to the card with low effort and ensuring consistency between design and development.
Let's talk about tokens in Swift and how we can achieve the same level of details that we saw in design. In order to do that, we're going to use protocols.
So, hello everyone, good afternoon. My name is Valeria Farina. I work as a product designer at Telepass. And what do I do as a product designer at Telepass? I work at the design system, and I ensure consistency across all of our applications because Telepass has more than one, so it's very important to stay centralized.
And I'm Firas. I'm a senior iOS engineer at TrueLayer. I work mainly on SDKs for payments using the open banking protocol. It's a whole thing, so if you're interested in it, we can have a chat about it. I'm on Twitter. I make a lot of bad jokes. And this is my website. You can find all my links, my GitHub repo with all the open source projects I work on. So let's get started. First, let's have a quick discussion about engineers versus designers. They both do really different jobs that go together. They argue a lot. They blame each other. They all have their own challenges at their jobs, which was really hard to explain. So we found a video on TikTok. We're not that old. So that explains perfectly how a normal day for a designer goes and how it goes for an engineer. So let's watch it together.
You say it's too late to make it, but is it too late to try? And all our time that you wasted, all of our bridges burned down. I wasted my nights, you turned out the lights, now I'm paralyzed.
Oh yeah, cool. So now, jokes aside, in order not to be in that situation, it's really important to have a well-designed application and website that offers a seamless and consistent user experience across your application, which helps build trust and user satisfaction with your clients. A uniform design ensures that users feel at ease while navigating through your application. They don't have to wonder what this color might, what this button of this color might do or not, because it's the same across the application. And it might be easy to maintain uniformity across a small application of a couple of pages, but the bigger the app is, it's going to be harder. As you know, more pages, more problems. And those problems can that can range from lack of consistency. So a color might be slightly different on one button compared to the other. The color can be, the radius can be slightly different, and so on and so forth. They can be the slightest things. Other than lack of consistency, it's going to be really hard to update, because if you hard code your values throughout the application and you have a big application, anytime that you have to modify it, you'll have to go to every single function, modify that value, and hope that you modified every single one throughout the application. Doing that means you have a lot of duplicated code, which, as we all know, it's a really not good coding practice, so we should avoid it. It will lead to an inefficient collaboration between designers and engineers, and each one will blame the other that they changed something that you didn't tell us, and so on and so forth. Or maybe the design made some decisions, changed it on one screen, not on the other. Engineers forgot something. So to avoid all of that, it can really lead to that when you hard code your values. And it's, let's face it, it's not scalable. If you have like 70 pages in an application and hundreds of components, and you need to do a slot modification, you cannot just go and modify every single value everywhere. So how can we solve this? Well, there's a few solutions. Solution number one, we can just map the properties to constants and use them everywhere. So for example, we can have the color white map it, and just in every single styling function that uses the color white, we can just use that. This obviously, you kind of have a single source of truth to what the color white is, so you get rid of the lack of consistency. The problem is here, it's still not scalable because you have a lot of repeated code. If the color white tomorrow becomes blue, you'll have to go to every single function again and change from white to blue, and so on and so forth. Another solution can be a design system with a high-level description. So it can use terms like background primary, background action, text editor, and these sort of things. While this is a bigger improvement compared to what we saw previously, it's still not ideal as it's non-descriptive. By that I mean when you use the same variable to reference different UI components, the day that button becomes, rather than background action secondary, again, you'll have to go and change it everywhere and make sure that it works, which is not ideal. So there is another solution, which we're going to present to you today. And to start it off, I'll give the mic to Valeria, which will talk about the design part of it.
So, thank you. As Firas said, our solution, well, actually, it's going to be a while till you see the solution, but okay, a little introduction first. So, some of you may know this man, some of you may not. You may try to guess his name here. I'll give you a moment. Yeah, who said? Brett, oh yeah, of course, but you're a designer. Well, he's Brett Frost. He's the inventor of atomic design. I'm sure everyone at least has heard the term atomic design. So what's atomic design is a methodology that structures UI into a hierarchy of components interconnected between them. Let's see just, quickly. The basic building blocks of atomic design are items, such as colors or text. They cannot be divided into smaller parts, like atoms. No? If you put together two or more items, you have molecules, so like buttons or search inputs. Put together two or more molecules and or items, and you have organisms, like headers or cards. Again, combine organisms, and you form templates, which are blocks that provide structure to your UI. And if you put content and real UI into these templates, then you have the final page. How does everything, translates into real UI design? So molecules are what we call components everywhere. Then we have patterns, blocks, and templates. Everything we use to build our interface. But can you notice that something is missing here? Can you spot the hole? So, what are atoms? If now we are used to think about components, and we said that atoms are the smallest part of the design, what are they? They are tokens. Actually, Brett Frost says that tokens should be considered as subatomic particles smaller than an atom. But if we said that atoms are color and text, and these are the basic building blocks of our UI, then these are tokens. Let's see, actually, what are tokens? Tokens can be a border thickness or a corner radius. They can be breakpoints across devices. They can be color, as I said, and form an entire color palette. They can be grid systems. Tokens are motion values for animations and micro-interactions. They are opacity values. They are shadows and elevation, spacing values, and last but not least, text. So I think we can all agree that there are no smaller parts than these. Why should we use tokens? Because design tokens help both designers and developers in maintaining coherence and theme management. We can see here from light to dark mode. They bridge the gap between designers and developers. They provide a shared language. minimize discrepancies, and they reduce the need for manual updates and back and forth communication. Why should we use them then? Design tokens support essential features, such as global theming, as we just saw, user customization. They allow the design system to adapt to evolving user needs. They actually make it easier to update the design system and introduce new themes, because changes can be made once at the token level, and then they automatically propagate throughout the entire system. They also serve as a centralized repository for design properties, ensuring that both designers and developers reference the same values for color, typography, and everything. By using design tokens, design properties can be easily applied and maintained across different platforms, from design, Figma, to iOS, Android, web, everything. And they ensure a single source of truth. How do we define a token? Here we can see an example from Atlassian design. You can see there are 5 main foundation tokens, they call them: color, iconography, layout, spacing, and typography. Here there's an example with color. So how do we define a token? We just set the raw value. In this case, since it's a color, it is a hexadecimal value, but it could be text, and so it could be text properties. We define the raw value, then we give a name to this raw value. In this case, it's purple 800. And then this base token, purple 800, will be used to create then every other design token that we need with this color. So we can have a color text discovery, like in this example, and then we can also have a color button primary background, I don't know, or an icon, or everything that we want to have this color, but properly named and assigned. Because now this, as I said, is the one single source of truth for everything, for design, code, and development, and everything. So how do we properly name a token to make it effective in its usage? As we just saw, the guys at Atlassian, they just give a more semantic naming. They actually use the foundation token first, color in this case, then what it's applied to, an icon, and then its semantic value, the meaning, so success in this case. But this is not the only feasible approach. For example, if we can see in the example below, IBM's Carbon system, they use a more technical approach. So they use border subtle 00, border subtle 01, 02. I don't know what they mean, but I think that they can actually use this. So what's the key takeaway from all this? What do we do? How do we name our tokens? Just follow the golden rule for everything, sorry. Do what fits you, your team, and your organization best. Just you do you, and that's it. Now, let's get down to the more practical part. For the purpose of this demonstration, we've created a simple NFT card. We used 4 tokens for this card that are corner radius, typography, color, and opacity. We will show you now how, by modifying only these 4 tokens, we can apply a totally different theme to the card with low effort and ensuring consistency between design and development. So, we created a couple of design systems for this. This is the first one, the Lime design system. We have text and color, and for both of them, we have base and design tokens. And then we have some icons, a button, and the image for our NFT card. Here we have the other design system, the vintage design system. Also, we have colors, typography. There's a one-to-one correspondence between the two systems. But I don't know if you can spot, there's one little difference from the other one. Who can spot that? No one, you weren't paying attention. There's one more base token here. we will see later how this will come to play and how this will effectively change the UI. So let's dive into color. What is color? When we talk about UI, the term color refers to a specific hue, saturation, and brightness values that we use to create visual elements within the user interface. It plays a crucial role in conveying meaning, establishing hierarchy, and reinforcing brand identity, as we saw in the talk before this one. It enhances user experience and improves usability. We can see now here our colors. You can see there's one brand color, the lime color, and then we have other base UI colors like white, dark, black. These base colors serve as the foundation to create our design system color library. As you can see, one base token now goes to form two different design tokens for two different meanings. One is for a promo icon, and one is for the primary action button. And so it will be for every other token we have. We assign them all to our elements in the UI. Now, here, you can observe the two design systems side by side. Although the design tokens for colors, I think you can observe they remain the same in number and naming, they are exactly the same, the base tokens they have been assigned are changing. So, let's dive deeper into this. In the first one, in the Lime design system, the brand colors base token is used for the primary button and the promo icon. On the second one, the vintage design system features two brand colors, a primary brand color and a secondary. Because we wanted to incorporate more color to the UI and give the brand more character. So we employed the primary color for the button and the secondary for the icons. If we compare these two libraries, it's important to note what I was talking about, the fact that we have one more base token. So this distinction is significant because having an extra base token allows us for greater flexibility. We can use one more color now, but not disrupt the entire library. If we manage to effectively manage and update these tokens, as designers and developers too, we can introduce changes easily or variations to themes, ensuring a consistent and visually engaging user interface across all different components and platforms. So here you can see in Figma how easy and fast it is to switch themes if every token is properly assigned. You see, there's a one-to-one correspondence here of every element, and then you have a card. So, super easy. So, now I'll pass the mic to Firas, and we'll talk to you about what you're interested in, the Swift part.
So let's talk about tokens in Swift and how we can achieve the same level of details that we saw in design. In order to do that, we're going to use protocols, specifically protocol composition and leveraging protocols to cluster each category of tokens that we saw together. Why protocols? Well, because protocols let you worry about the what, not the how. So by that I mean, when you use protocols with the tokens, you only have to worry about what token you need to use in that specific place and not have to worry about how it was implemented, what values were assigned to it, and so on and so forth, which makes your life much, much easier. So let's get down to business. What we want to achieve at the end is have an object that conforms to this protocol, which is the design library provider, which has the colors, texts, and miscellaneous stuff we use throughout the application. So the first thing we're going to look at is the color. Again, it's another protocol. So the color tokens provider contains the colors for the icons in the app, the texts in the app, and the background colors in the throughout the application. So how are these then used inside to create the actual card? So as we can see, let's take first, for example, the icon. So the icon, again, is another protocol in its turn, and it contains the concrete tokens that we're going to use at the end of the day, which, for example, for the icons, we have the icons that are going to be throughout the app inside of the primary button, or throughout the app where we have a promo and we want to use that color, because, again, we said it has to be consistent throughout the application. Same thing we're going to do with the text. So as you can see, a single token can be used for different elements when it makes sense. So in the case of the text throughout the app is going to have the same color, roughly, except, for example, in this case, inside of the button, it's different, so it has its own token. But throughout the app in general, it's going to be the same. So we recommend using the word standard, which is like, it's a standard thing used throughout the app. Same thing for the background colors. So as you can see, we divide them in, for example, card details. It has its own background. As you can see, it's not quite dark, like it's not full color. We'll see how we do that later. Same for the button. So the button primary colors throughout the app will be mapped to a single token. Then let's go to the miscellaneous stuff. It can contain the various stuff that we want to tokenize. Stuff like the corner radius, the opacity, and even the assets, really. So for example, the corner radius, we map them, again, single tokens for the cards throughout the app. They're going to probably have the same ones. Let's say you have 3 types of cards. You're going to have card primary, card secondary, card tertiary, or any way you can describe them better. And then you have the radius for the buttons, which again, you most likely are going to have 1 to 2 throughout the SDK, throughout the application, to make sure it's consistent throughout. Then we have, for example, even the opacity. So the opacity in this case, as we saw, it's not quite 1, so we have a token for that, so we can modify it. And if tomorrow this opacity becomes 1, just set this value to 1, and it's updated throughout the application. And last but not least, the assets. So realistically speaking, if you have this design in your application, this asset is probably coming from an API. But just to, for the purpose of this demonstration, let's say it was mapped, hard-coded inside of your bundle. So you can just map that name of the card. And again, probably the name of the asset itself, it's probably going to be, I don't know, girl on a bike with orange hat or whatever. But for the purpose of your use, it's going to be card background. So the background we use throughout our cards, it's going to be this. So this is the token for it. And basically, we get all of these tokens, and we're going to go through the code right now real quick just to see how we did it. It was built using SwiftUI and ChatGPT because I was way too lazy. So I just told them what it needs to build, and it did it. So the first thing we notice is we inject the design library inside of our view. So there's different approaches to do that. You can obviously use a singleton for the design library and have it in one place and call it from everywhere. I'm not a big fan of singletons, especially when it comes to testing, a whole other discussion. We don't have to have it now. But let's say we just inject it. However you want to reach it, you just reach it. And as we can see, we just inject the protocol, not the concrete type. Because again, we said we don't care about what those actual values are. We just care about the tokens that exist. So as you can see throughout the code, all we do is access the design library, miscellaneous, for example, corner radius, and that way we can set the corner radius of the card. Same thing we do for colors, we do for the text, and everything really. That will help us, like, again, not worry and not have to ever touch this code ever again, unless, again, something like you change, obviously, the actual code. But as long as it's corner radius being changed, colors, or anything really that has to do with designs, we don't have to worry about it at all. So let's go and see the actual then implementation inside of Swift. So if we take the Lime library that Vale showed us before, we start off by the base colors. These are the concrete raw colors that we have inside of our application. So we have the brand primary, brand secondary, white, dark, black, and cream. These are the lowest level elements that we have inside of our library. We then, and again, this conforms to its own protocol, because again, it will help us make it easier for us to customize it in the future, especially when working with the SDKs, which we'll talk about later. So then we take these base colors and we inject them in our different cluster of token colors that we previously saw together. So these again are concrete types that conform to the protocols we previously saw. And they just take in that base color and we assign it to the values that we have. then all these small clusters will make and compose our color tokens, which is the higher level tokens that we have inside of our code. Same thing actually works for the font. So, for example, the button font is standard because usually the font throughout the buttons is probably going to be the same. You set up the font for that, for the button font, it's a standard. But the card, however, if we saw earlier, it had the title that was different from the body, different from the price. So each of those will have its own single token. And these will create the cluster token for the font tokens. So now we'll have eventually the miscellaneous tokens, the font tokens, and the color tokens. And when we put all three together, we're going to have our design library concrete object that conforms to the design library protocol that we saw earlier. So basically, by injecting inside of that code this design library that we just built together, we're going to automatically have this card. And if we exchange it with an alternative design, which basically it's going to be the same thing, but with different actual values, so different colors, we're going to have the other design. Now, maybe you don't believe me, which is fine, so that's why we have this. So as you can see, by toggling the toggle on top, I'm using the same view. I'm just simply injecting a different design library in it, and it automatically changes the whole looks of the card. So that's basically how you can do what we went through code. Other use cases can be, as I mentioned, SDKs. Why I mentioned that is actually where I work, we work a lot with SDKs, and we work on an SDK that is used by third parties, so other companies. And companies want to have their, it's a payment SDK, so it has a whole flow of payment submission of your, selecting your bank, submitting your card, your information, etc. etc. So by using this type of design library and these protocols, we can provide this protocol publicly to our clients, and all they have to do is provide us with these values that they want, and we can modify the UI for them automatically on the go. Other stuff we can do, obviously, for more complicated scenarios is using that design library to create more global components. So you can probably use all these tokens and inject them into a button primary, where inside of that button primary, you will set the background color, the text color, and so on and so forth. Future development, this is an idea that we had like 5 minutes ago. I don't know if it's feasible, but if it is, we'll probably work on it. So basically, as most of you use Figma, we sure do at work. If you can even find a way to have Figma, once you set up your design library, upload those values to a repo somewhere by obviously mapping them one by one with your engineering team, then you can, at that point, you can 100% have a unique source of truth throughout the application, where you don't even have to modify those values. All you have to do is call the service, download the JSON, map it to your types, and you're good to go. Everything we showed you today, you can find it online. The first one, the GitHub repo, contains all the source code, and it's going to contain these slides as well. I'm going to upload them later. And there you can find the two public Figma projects that Valeria worked on. And we're going to upload as I said, the presentation, which I hope you liked it. It was done with Keynote by Valeria, so I want to thank her for that and for her patience with me, because I changed my mind a lot. So that's it. Thank you, guys. And